Automation software powered by machine learning feeds on big data, but the type of big data is pretty important. For ZDNet and Tech Republic, I'm Dan Patterson, and here to discuss the data that feeds artificial intelligence is ZDNet contributor George Anadiades. George, thanks for your time today. Your expertise is big data that feeds automation, machine learning, and artificial intelligence. Tell me a little bit about the libraries of data that feeds AI.
Sure, thanks, Dan. And yes, you're right. There is, in fact, a very closely knit connection between big data and what we call automation. And before going into that, it would be good to actually shed some light into what automation really is about, because these terms are kind of used interchangeably these days, and it's good to actually know, the difference. So automation is like the broader term of, well, automating functions in software or elsewhere. And artificial intelligence is a sort of narrower term, and machine learning is just a specific branch of artificial intelligence. Now, the thing is that for machine learning to work, it needs a lot of data. Because machine learning algorithms have to go through something called training, a phase of training them, through which they actually learn to identify patterns. So this is where these two words sort of meet, in fact. So you need big data to feed machine learning so that you can have automation. And there's different ways in which machine learning can be actually consumed, let's say, can be consumed and can also consume big data. So one way you can use machine learning is to use it as a library. That means that you have to have developers and data scientists that know how to use these libraries, and this can happen on premises or in the cloud. And there's plus and cons in each scenario. And then you have a second case, which is using machine learning in what we call integrated environments. So these go a step further or above plain libraries, in the sense that they give you a whole integrated environment, pre-integrated actually, that makes the lives of people that have to use that easier. So instead of going and teaching all the components by hand, they have this pre-integrated software that lets them do their job in a much easier way. And then there's a third way, which is actually what we call embedded analytics, or automation in that case, if you want to call it that, which is basically about enabling everyday software to have superpowers. So that basically means that somebody else has done all the hard job for you, and these capabilities are already in the software that you use. And so it's your algorithms are already trained, and your data, the plumbing is already done for you. And so you are basically just free to consume the end features without having to spend effort into developing and integrating them in your pipeline. So,
George, how can big data train machine learning or automation to do specific tasks that are pretty diverse? For example, machine learning can do everything from identify faces used in consumer applications like Google Photos or Facebook, but it can also be used as a security defense mechanism for large enterprise companies. How does big data train artificial intelligence machine learning to do specific tasks?
Well, you have certain classes of machine learning algorithms that can be sort of customized for your specific domain. But the truth is that the customizations of the algorithms themselves are probably not the most important thing. The most important thing is actually the data that you use to train these algorithms. So things like feature selection, which is basically about deciding what parameters of your data are important for your model, and then having a good having good data sets for training, which means that they should be substantially big, so that you can have good coverage of your cases, which enable you to do reliable predictions. But that's only one part of the equation, actually. So yeah, big data tools enable you to collect and store and organize all that data that you eventually want to use for machine learning. So that's one part of the equation. The other part, the interesting thing that we have started seeing going on as of late is that, well, machine learning is not just something that is powered by big data platforms. It's also something that big data platforms use internally to boost their own capabilities and performance. And so, for example, we have been seeing machine learning capabilities being added to tools to do things like data wrangling or server provisioning or even application deployment and data analysis. So if you're an analyst using your analytics tool, you can be assisted in your work by machine learning algorithms running behind the scenes and giving you suggestions of what you should be looking at, for example. And this creates an interesting sort of feedback loop. So the more data you have, it means that your machine learning algorithms can run better. And this in turn means that you can improve your software, in that case, your big data platforms. And by doing that, you get to produce even more data. And so you see how this feedback loop is going to be operational.
George Anadiades is a contributor to ZDNet. You can follow all of his posts about artificial intelligence, machine learning, and big data on ZDNet. George, I wonder if you could leave us by telling us about the snowball effect that results from that feedback loop. Like you said, more data equals more effective machine learning, equals better data tools, equals more data. That creates a snowball effect. I wonder if you could leave us by describing that snowball effect and what's achieved by that feedback loop.
Well, that sort of leads us into uncharted territory, I would say, because, first mover advantage is going to get to a whole different level through this snowball effect. And the thing is that you may get to the point where you have sort of new monopolies forming, and it's going to be very, very hard to regulate those monopolies. So this is something that should be given some thought now before it's actually too late to do something about it.